Alright, we're going to look at a function, a parameterized function, and look at the second derivative. So if we have our parameterization as x is following y, x equals t minus t squared, and y equals t minus t cubed. And we're not giving an interval here, but we're asked to find the second derivative of y with respect to x. And so if we look at how we defined this previously, we're going to look at dy prime with respect to t and dx with respect to t. And so the first thing we want to figure out is we want to find y prime is equal to dy dx, but dy dx is dy dt over dx dt. That's our first step, is to find. And so we'll want to find dy dt and dx dt. So dx dt, coming up here, is 1 minus 2t, and dy dt is 1 minus 3t squared. So y prime is 1 minus 3t squared over 1 minus 2t. And so we want to find dy d prime over dt. In other words, we want to take the differential operator of d dt on 1 minus 3t squared over 1 minus 2t. And we've got ourselves a classic quotient rule going on here. U equals 1 minus 3t squared. So du, u prime, equals negative 6t. And v equals 1 minus 2t. So v prime equals negative 2. And if we take our quotient rule, then this is going to be first v times u prime minus u times v prime over v squared, which will give us 1 minus 3t squared minus 3t squared 1 minus, whoops, that's 1 minus, this should be 1 minus 2t, because v is 1 minus 2t. I almost gave u instead of u prime, and then u prime is negative 6t minus, and then in u is 1 minus 3t squared times negative 2 all over 1 minus 2t quantity squared. And a little cleanup upstairs. Let's see, negative 6t plus 12t squared minus 2 times 1 is minus 2 plus 2. And minus 2 times negative is minus 6t squared all over 1 minus 2t quantity squared. And so, let's see, I'm going to get a positive 2, a negative 6t, and a plus a 6t squared over 1 minus 2t squared. So we have dy dt. And so if we put all of this together now, we have we have our dy prime dt. So I guess we can stitch all of this back together. I'm going to have this upstairs, 2 minus 6t plus 6t squared, divided by 1 minus 2t quantity squared, all over 1 minus 2t. And I note that this will give me 2 minus 6t plus 6t squared, and I will end up with 1 minus 2t cubed in the denominator. And so we have our second derivative. These are fun. Said slightly sarcastically. It is a bookkeeping job, keeping track of some things. I find keeping dy dt and dx dt, I think noting how dx dt appears twice, once in y prime and once in the second derivative of y with respect to x, and that repetition is just something to watch out for. All right. Again, I'm going to do these in little parts, so I'm going to save that part and then we'll look at the astrid as a separate example.